Hello everyone. Today we are going to discuss about Meyerhof's bearing capacity analysis. We have seen how to calculate the bearing capacity of a foundation by using Tarjag's bearing capacity equation. Tarjag's analysis is for general shear failure and for continuous footing. Whereas Meyerhof bearing capacity analysis takes into consideration different shapes, depth effect, inclination of the loading, all those things. So it's quite versatile. It's a good improvement over the Tarjag's bearing capacity equation. And also in Tarjag's bearing capacity equation, the shearing strength above the base of the foundation was neglected and it was replaced by the surcharge. Whereas in Meyerhof's bearing capacity analysis, he has taken into consideration the shearing strength of soil above the base of the foundation. So that's one thing. And second thing, he has considered various shapes so it could be a square footing, rectangular, circular, any kind of footing, so various shapes, so shape effect, also depth effect, depth of the foundation, and inclination effect. Of the loading. So that's the improvement in Meyerhof's bearing capacity analysis over Tarjag's bearing capacity analysis. And the equation, the ultimate bearing capacity is given by equation QU equal to CNC into SC DC IC plus Q bar NQ SQ DQ IQ plus 0.5 gamma Bn gamma S gamma D gamma I gamma. So this is the equation for ultimate bearing capacity of a shallow foundation given by Meyerhof, and it's a considerable improvement over the Tarjag's bearing capacity equation, where SC, C you already know, C is the cohesion parameter, NC, NQ, N gamma. These are bearing capacity factors, and these are the function of phi. And this SC, SQ, S gamma are the shape factors. DQ, DC, DQ, D gamma are depth factors. And IC, IQ, I gamma are the inclination factors. So this equation 1 should be used for computing the ultimate bearing capacity. If you want to find out the net ultimate bearing capacity, then you already know that to compute the net ultimate bearing capacity, what should be done? To compute the net ultimate bearing capacity, what you do it? The ultimate bearing capacity minus the surcharge. So surcharge can be taken out. Surcharge should be deducted, and that gives you, where Q bar is called effective surcharge. And this effective surcharge is taken as equal to gamma prime, the effective unit weight of the soil above the base of the footing, into depth of foundation. Say you have a footing embedded into the ground, the depth of footing, the width of footing. Then here the effective unit weight is gamma prime, and below the base of the footing the unit weight is gamma, and that gamma comes over here. So 0.5 gamma B N gamma, S gamma, D gamma, I gamma. Now the question is how to find out this SC, SQ, S gamma. So the shape factors, first we should try to find out the shape factors. To compute the shape factors, you can easily remember this. Shape factor is given as 1 plus 0.2 into the width of the footing divided by length of the footing. If it is a square footing, B L equal to B. Otherwise, if it is a rectangular footing, B by L into tan square 45 plus 5 by 2. So you can use this. And if it is a strip footing, then SC, SQ, S gamma equal to 1 for strip footing. For other shapes, this is a shape effect. SC has been taken as 1 plus 0.2 B by L, where L is the length. B and L are width and length of the footing respectively. And phi is the angle of friction that you already know. So this is also called tan square 45 plus phi by 2 is also given as n phi, or you can write it like this. Then another shape factors SQ and S gamma are given as 1 plus 0.1 B by L into tan square 45 plus phi by 2. So all the shape factors you are in a position to calculate. Then how to find out this depth factor? DC. DC is called depth factor. So DC needs to be found out. So DC equal to 1 plus, like SC, DC you will have to calculate, you can, the depth factor 0.2. Now it is a depth factor, so it will be depth of foundation footing divided by B into tan 45 plus phi by 2 for phi greater than 10 degree, and it is equal to 1 for phi 0 degree, right? So you can remember it very easily. Then another depth factors should also be computed. The easy way to remember are the depth factor DC dq and d gamma will be given by, like SC/SQ, like SQS gamma. Here also dq d gamma will be, depth factor will be 1 plus 0.1 depth of foundation divided by the width of the footing into tan 45 plus phi by 2, for phi equal to phi greater than 10 degree, otherwise 1 for phi equal to 0. Then comes inclination factor. Inclination factor will be IC, IQ and I gamma. So what is the inclination factor? If this is a footing and the loading comes over here, over the footing, in such a way that the load is going to be inclined, you will have two components, one vertical, another component is going to be horizontal component. So, and this angle is called angle alpha. So, IQ is given as 1 minus alpha by 90 degree. This is the load. All square. And I gamma is given as 1 minus alpha by 5 whole square, where alpha equal to tan inverse horizontal component upon vertical component of the load. So this equation is universal in nature, which takes into the effect of shapes, depth, inclination of the loading. You can calculate for any shapes. So that's a kind of equation given by Meyerhof. And in GATE examination, you will find a lot of questions on Meyerhof bearing capacity analysis, bearing capacity equation. Now, I told you that NC, NQ, and gamma are the bearing capacity factors. How will you find out those bearing capacity factors? Very easy way. NQ, the bearing capacity factor, can be computed by using the equation given by Meyerhof, e raised to pi tan phi whole multiplied by tan square 45 plus phi by 2. And NC, another bearing capacity factor, CNC. So NC will be given as NQ minus 1 into cot phi. And N gamma is another bearing capacity factor, 0.5 gamma B N gamma. So N gamma is given as NQ minus 1 into tan of 1.4 times phi. So these are the bearing capacity expressions. And these values are given in Meyerhof bearing capacity factors in a tabular form. So as you can see, these are all functions of phi. These are all functions of phi, and naturally you can get it from the table given by Meyerhof, and it will be given to you, supplied to you in the examination. So it will be known for the given phi value, what is the value of bearing capacity factors in the question paper. So it will be, so you need not worry about it. So, but you will have to remember shape factors, SC, SQ, S gamma. You will have to remember the expression, calculate it, calculate the depth factor, DC, DQ, D gamma, the expression which I have given to you. And if the loading is going to be inclined, then you will have to calculate IC, IQ, I gamma. So all these things in a very lucid form I have put it for all of you to remember in the examination. In the next video we will take up few problems over this and we will solve it here. Thank you very much.